All right, good morning, good afternoon, wherever you are joining us from. And welcome to today's webinar, Web-Based Component Design with RISACalc. My name is Ben Follett, and I'm the Director of Sales and Marketing here at RISA. Today, we're going to dive into all things RISACalc, which is the new web-based component design application from RISA. And so before we do that, just a few housekeeping items. Maybe it's your first time using a Zoom webinar. Maybe you've done this obviously throughout the coronavirus. Maybe you've done this 100 times, but you have a few different audio options. You could either use your phone and call in with the phone call numbers that you received in your email. You could also use your computer audio, which is like what I'm using right now. Use your headset. Also, we want to make sure that if you have questions, you get those questions answered. And so there's the Q&A box there in the bottom navigation of the Zoom meeting. So my colleague Gabby is actually manning that QA box, and she'll be able to answer your questions throughout the meeting. So if you have anything, please don't hesitate to put it in there, and we'll get it answered as soon as possible. And so without further ado, let's go ahead to jump in to talk about RISACalc. And so it's a web-based application that we are beyond excited about. It's something that we've been working on for quite a while, and really excited to now kind of debut it and have our customers, both new and old, get their hands on it and give us their feedback and try things out and help us to continue to push a product like RISACalc forward. So at its core, RISACalc is a web-based application that allows users to quickly and easily analyze single members, beams, columns, composite beams, joists, using a variety of different materials. And we'll look at some of that in a minute here. Really, what we focus on is an intuitive open interface that makes model setup really easy. You can choose really quickly the design criteria, apply very simple loads, and then view the results both graphically or in detailed reports. And really, we're taking a lot of the power of RISA 3D and a lot of the same functionality, and we'll see that in like the really nice new detailed reports. And we're putting that into the cloud in an interface that allows engineers to collaborate in real time and really focus on getting things done, quickly and efficiently and easy. And so the question that we asked ourselves, the question that people have been asking us, why create RISACalc? And so I came up with a few different things that, as I've been pondering this question, as I've been talking to customers about it, really creating RISACalc as a fast and convenient tool to easily analyze members without the need for a full 3D model, right? Not everything that we do as engineers requires a full 3D or even a full 2D model that you would build in RISA 3D or RISA 2D. And so sometimes you just need to do a quick check. And so, in a lot of ways, and I'm jumping around a bit, but in a lot of times we currently use our hand calculations or spreadsheets or some other design tool to do and complete these repetitive tasks. And so that's for us one of the places that RISACalc fits in. Additionally, I think it's a really straightforward approach for the review and investigation of existing conditions, right? You have to analyze an existing joist or an existing composite beam, and you just need to, you know what it is, you know what the drawings tell you, but you need to add additional loads there and check to see if that's okay. You don't want to build a full model for that, right? It also eliminates some of the headaches that are consistent with 3D models, right? You may have instability problems or connectivity problems, or, do I have the right boundary condition problems, right? In those cases, having a simplified interface, having a single model approach eliminates those things, right? I also think it's a really good option and a logical first step for entry-level design for entry-level junior engineers. I know when I started working at an engineering firm at 23, the engineers, gave me a great gift in the sense that they didn't allow me to use 3D software right away. They said, hey, you're going to do things by spreadsheet and by hand and using other small softwares so that I could learn the engineering, characteristics of a project so I can understand better and take my academic knowledge and apply that to a real world understanding of structural engineering. And so I think that in all of those ways, RISACalc can be a great help. And so when we look at what RISACalc is today, RISACalc focuses on different materials and codes in different jurisdictions. So we have concrete column and concrete beam design for both US and Canadian codes, steel joist design for the US codes, composite steel beam design for US and Canadian codes. We also have wood beams and columns, again in the US and Canadian codes. stainless and, well, steel and stainless steel beams and columns, and then finally cold form and aluminum beams and columns. And so really a wide range of materials, a wide range of component types that you can do. And like I mentioned before, we do have some other code types other than American codes and Canadian codes. There's some, for instance, the Mexican code for the cold form steel and the Saudi or Indian codes for concrete. So different things that that you can use, but mainly for the US and the Canadian codes. And now these are the starting point for our components. We're always looking to, and we'll talk about this a little bit later, the next components, the next things that we're going to develop and the next things that we're going to add. And really, this is where we need your help. I also want to talk a little bit about the fact that this is our first fully cloud-based application, right? And so what are some of the benefits of the cloud-based application, right? Well, there's no installation on the local machine. So you're not downloading an exe file and putting that exe file on your machine in any way, shape, or form. There's no licensing on the local machine or the local network, right? So you can do a single license or a network license in the cloud that can be shared across users, something that I think is super valuable, super important, kind of as we see the workflow for daily, for in office or out of office or work from home, kind of this work share program, as that starts to change in our world, that licensing in the cloud and not having to be tied to a network could be really valuable. Also, we can share models in the cloud, right? So we're able to easily see a file structure and share the models that we have with other colleagues, with other engineers in the cloud. And so without just spending any more time in a PowerPoint, let's go ahead and jump right into RISACalc. So I'm going to go ahead and switch really quickly here. And I'm on kind of the home page, the landing page, if you will, for calc. It's at calc.risa.com. This is the landing page that if you were logging in for the very first time that you would see. And so from the landing page, we just have some basic, criteria, and we'll talk a little bit about some of the other resources available later. But I'm going to log in with my RISA credentials. If you're already a subscription user for other RISA software, it's going to be the same credentials if you were to go ahead and buy a license of RISACalc. So I'm just going to put in my credentials here, and I'm going to click login. And so the first thing that we're presented with here is Project Explorer window, as I like to call it. And so we could start a new project from scratch. So a beam, a column, a joist, or a composite beam. We could access some resources, what's new, release notes, or the learn section of our website. And again, we'll look at some of those resources a bit later. Or we can go ahead and open up a recent project. And so I'm going to actually open up this first project here. It's kind of my test project. And so in this now, I'm going to go ahead and create a new beam, kind of a new place to start here. So I'll just create a new beam, and we'll look at some of these other elements that I already have in my model here. But let's take a look at the interface first, right? And so we have kind of three main, kind of locations or interface items here. The first here is the Components tab, right? So we've got the Components tab that is an organizational way to show all the different components that we have. So we've got our beams, our columns, our joists, our composite beams. And so we have all of that information there. We also have our kind of main viewport, if you will. So this is where we'd see things in 3D. We could select the different parts of the model. We can make some changes to how things are being viewed. We could lock the view or allow to zoom. Right now I have the zoom locked, so I'm not zooming in and out if I'm using the roll ball there. I also have the main buttons for toggling on the unity check and the loads and the boundary conditions. Finally, I have the Properties tab. So this is kind of the main driver, right, where we're going to set up all of these different things, the different criteria of a particular member, and we'll walk through some of these different sections in this Properties tab in just a moment. Before we get into any specific design for any specific member, I do want to go ahead and launch here, clicking on this gear icon, which is essentially the settings, right? And so when I open the settings, the first thing that we see are the codes, right? And so the various codes, like we talked a little bit about, that exist. Hot rolled steel, we can see all the codes that are available. Composite steel beam, cold form steel, concrete, we can see concrete, and then concrete has some different criteria that we'll look at a little bit later. Wood, aluminum, stainless steel, and steel joists. So all of the different all the different codes that exist here. We can also go ahead and look at our unit settings. So whether we're using a default imperial or a default metric unit setting, or we want to modify that in some way to use a hybrid setting, we can go ahead and do that. We also have some composite different code criteria. And we'll go ahead and look at that a bit later when we look at a composite beam. And then finally, we have just some basic user criteria, which is really more of a drawing text size, just to make sure that you're being able to see things visibly correctly. And so I'm going to go ahead and start with a beam. So let's start with a wood beam. We have our code set here. So I'm going to use the NDS 2018 ASD edition. So I'll just click apply. And the first thing I need to do, if I'm in any beam, I need to set the material. So I don't choose if it's a right off the bat out of components, if it's a wood beam or a steel beam. I'm actually picking here what type of material I want. So I'm going to choose wood here. And as soon as wood starts, and this is pretty typical of really any type of member in RISACalc, we have some options for the properties of that member, for the definition of the properties. So I can choose a solid sawn member, and then if I keep on solid sawn, I've got some different options here. In this particular example though, I'm going to choose engineered wood, and we can see that our options change a little bit, right? And so under type, we can see we have glulam, LSL, LVLs, OSLs, PSLs. So I'm going to choose a glulam member to start here, and then we can choose the database that we're going to work from. And so I could pick a different, database and then kind of see the different material types in that database. I'm going to go ahead and keep to the NDS table 5A, and then I'm going to go to, let's see, a 24F 1.8, let's see, DF, or let's do an SP balanced. Yeah, let's do that. So we've got our material type set. Then I could set my shape type, so nominal, net, or round. I'm actually going to do, I don't want to do a nominal shape where I'm just picking from the database here, right? And we can see all the information for that particular wood shape and enable some additional advanced properties. I'm actually, though, going to use a net shape and plug in my width and depth. And that's really kind of how glulam members are defined anyways. So let's do the width here at 3.5 inches. And then let's do the depth at 13.5 inches. I could also choose a rotation if I need to. So, I can choose a 0 or 90-degree rotation. And then again, if I click the gear here, we're seeing the properties of the material. So all these properties right out of that NDS table 5A. We could also enable some additional things, that NU, the modified modulus, and then the CM factor, as well as our geometric properties for this particular member. So now that I have my member defined and the properties, I can go ahead to the span here. And so if I click span, or if I click the member itself here, we can go ahead and start to see the information we need. So it's span, I've got a 10-foot span by default. I can see the left support and the right support boundary conditions, and we can see these obviously very graphically as well. So we can see I've got a pin here and a roller on this side. I'm going to go ahead and add another span. So I'm just going to click add here. And let's make that span 4 feet. And then that rightmost support, I actually want to make that free. So I want this kind of back span cantilevered condition that I have here for this particular glulam member. Now notice, I can select things in the properties here, but as soon as I select something graphically, whether I select this boundary condition, it's automatically selecting and highlighting the left support, or this dimension, it's automatically selecting that span. So we have this interactive, dynamic way to look at information and access information, both in the graphical viewport and in our properties panel here. And so really that can work back and forth. So if maybe you just want to run through the panels, you can do that. Or if you want to interface things graphically, or you're not sure, okay, where is this dimension and what does that relate to? You can just click on it and it's going to open that up right away. And so I've got these different spans now. Now let's go ahead and look at the design tab. For most of the elements in RISACalc, the design tab is first and foremost going to start with the bracing, the bracing conditions. So is it braced for out of plane, right? We're only really working in 2D here, right? So we're not worried about the out of plane, if you imagine in and out of the page here, or in and out of your screen. And so are we braced for out of plane, or are we braced for in plane? Are we braced at the top flange? Are we braced at the bottom flange? Where are we braced, right? Are we braced fully? Are we braced at supports? We have those different conditions. And so in this case, I'm going to go ahead and say I want out of plane bracing at the support conditions, and also for the top flange at those support conditions. So just manipulating and modifying those factors that are going to be incorporated when we do our design. Now we always have some other criteria here. We can set a K factor, right? We can set our in-plane side sway from bending. If we want to go ahead and enable that, we could also set a CV factor if we want, or right now we're just going to go ahead and allow the software to auto calculate that for us. So at this point, we have different, we have different kind of the member set up. If we wanted to add more spans, we could, but that in that case, we're jumping back in a span and we're adding, an additional span, and then we're manipulating a span. So like if we wanted this first span to be a cantilever and then we wanted a mid span, we'd set this to be, free here. And then now we put another span in and then have a front span and a back span. We can do a variety of different things to kind of make the model that we want. Now, if I go ahead into loads, we can apply point loads and distributed loads. And so as we add these loads, we can add them into various load cases that will all allow us to create load combinations automatically. So I'm going to go ahead and start with point load. So I'm just going to click the plus button here. And so I'm initialized into a load here. So is it a load vertical? Is it a load horizontal? Or is it a moment, right? A point moment. And so we can set a magnitude. So let's say I'm going to do half a kip, and then I'm just hitting tab to get through. And I want this to be a dead load. And then where do I want this located? So let's make this at the 7'5" dimension, right? And see, I don't see anything right now. I see my dimension here, but it's because I have my loads turned off. So let's turn our loads back on there. And so now I've got that at the 7'5" dimension. If I select it, it would open that right back up. Let's go ahead and put in another point load. So I'm going to put in a live load this time, and let's make that magnitude 1 kip, and it's going to be a live load. And let's make that location, that same location, 7'5", or 7.5 feet. And so now we've got those 2 point loads applied. The next thing I want to do is let's go ahead and add some distributed loads. So let's click the plus right next to distributed loads. And the first distributed load I want to add is 250 pounds a linear foot. So let's do 250. And we can make that dead load, that works. And let's make that along the full length here. And we have a couple options for how we want to input that length. I can just click on this equals, or this percent symbol, and I can change it from the percentage. So we could do a percentage, hey, 35% of the way or something, or I could input a dimension itself. So with the dead load, let's go ahead and add one more load. I'm going to make this a live load, and let's make this, actually, you know what? Let's make this a snow load so we can get some different load combinations. And I'm going to make this a variable snow load. And so let's go from 1.25 to 0.375. So we've got this variable snow load that's linearly increasing from the beginning to the end, and from the 0 to the 14-foot location. So if we look here, now we've created these loads. I can go ahead and expand load combinations, and it's building my load combinations for me, right? And so if we wanted to manipulate or modify these load combinations, we could. So I'm going to click on the gear again here, and we can choose the region and the basic code and the year that we're setting here. Now we're doing an ASD design, so I'm going to go ahead and eliminate the strength combinations. So we don't want the LRFD combinations, we just want the ASD combinations, keeping self-weight in tune there. So if I click done now, we've got our basic ASD combinations. And this, we can verify this. We didn't have to create this ourselves, but we can verify, okay, dead load, dead plus live, because we have a live load, point load, dead plus snow, dead plus 0.75 live, dead plus 0.75 live, plus 0.75 snow. Okay, that makes sense. Those combinations, and we can see the reference they're coming from, those combinations are what I would expect from a model like this. So at this point, we're ready to see results. So I'm just going to click the check mark real quick to toggle the analysis, and we start to get results, right? And so the first thing that we see is we've got some graphical result options that are available to us. We also see the code check, and it gives us the governing load combination. So not surprisingly, we have 1.0 dead load plus 0.75 live plus 0.75 snow is our controlling combination. Not overly surprising. If I look at view here, we could view any of the other combinations or see any of the load categories we wanted to. I'm just going to leave it on the governing one here. We could also go ahead and look at some of our force diagrams, right? So if I look at shear, for instance, we see our shear diagram here, right? So we see our max at the support here, at the mid supports, and where it zeroes out at the cantilever. We could switch here to moment and see, kind of the moment diagram, obviously, that we would expect. We could look at reactions, and we could even look at a deflection, right? A deflected shape as well. And so we can see all that information graphically on the screen. Now I can also expand here just by clicking that little arrow, our detailed report. And so we have a bunch of different sections of the detailed report, right? We could start with properties. So it gives us all the defined criteria that we saw in the properties and span criteria anyways. We could see the loads that we have applied. All that information is great. I just like looking at the calculations because this is where we start to understand, okay, what's required, what's available, and what unity check is controlling, right? So in this case, if we look at our shear analysis, we can see step-by-step how our shear analysis arrives at a specific unity check, right? So see that little s prime v and big F prime v and how that's calculated so that we can see precisely, you know, what a RISACalc is doing. So this is really straightforward for a wood member. Let's go ahead now, instead of creating another member from scratch, I want to switch to looking at an existing member. So I'm going to look at this concrete column. So I'm just going to go ahead over here in components and I'm going to select my concrete column. And so in this concrete column, I have a few different things. So if I turn on my loads here, I already have the model run. And again, maybe this is an existing condition, right? And so maybe this was a model that was done by another engineer and he sent me a note and said, hey, Ben, can you look at this particular element, kind of maybe either update it or figure it out, or maybe it's an existing condition that we need to present our findings to the owner. And so in this case, if we're looking here, we see right off the bat that we're failing. We've got a 1.09 enveloped code check with the governing combination being 1.2 dead plus 1.6 live. And we can see that I do have a small wind load on us here, but we also have a big live load right here and a big dead load at the top here. And so if we go ahead and look at our detailed report, one of the things you'll notice, especially when you get a failure in any particular member, you'll see a message, right? And so this message, first off, isn't really a failure message. It's just more of a warning in this case, but it tells us that the compression PU exceeds 0.75 times PC for Euler buckling. So that's just a warning. We can also go ahead and look at our calculations to see, okay, really where our failure is in axial capacity. So we're required to have 235 kips. We actually only have 217 kips. So we need to start kind of modifying or refining this condition, this concrete beam or concrete column design, excuse me, in order to get a passing check. So I'm going to go ahead and kind of make that detail report go away. And the first thing I'm going to do is I'm just going to open up my settings here. And we saw this maybe briefly before, but I'm using the ACI 31814 code right now. I'm going to go ahead and open up the gear. And we do have a few additional options for concrete. And so I can choose my concrete stress options, rectangular stress block or a parabolic stress block. I can choose if I want to use cracked sections or not. We can also choose some minimum percentage of rebar and maximum percentage of rebar for a column. In this case, I'm going to leave that as is because those are really the code defined parameters. Next, I can go ahead and start to really evaluate the properties of my member for a concrete column and see what I can change. So the first thing is I'm looking at the properties here. I see I have an 8x8 column and my rebar says I have minimum flexible bars. So the minimum vertical bar is at 6s and max is at 8s. Now I can select at any time, I can select with a concrete column or a concrete beam, I could select the dimensions or this other information to open up various parts of the property. So for instance, if I select this 8-inch dimension here, I select the 8-inch depth. If I select this min max 8, I get the flexural rebar. If I select, for instance, the number 3s here, I get the shear open. And then if I select this 1.5 inches, it opens my cover, right? So we can start to manipulate things. So I think one of the ways I want to start is let's set a larger max flexural bars. So let's go up to from a number 6 to a number 10. That may be something that we need. And so I can go ahead and, toggle on the unity check to see if that solved any of our problems. And so it did solve our problems, but it did solve our axial problems. So we have more axial capacity, which is, isn't surprising, but we still have some problem with, with Euler buckling. So this tells me that we need more area of concrete, right? So I'm going to go ahead and make this, I want to keep a square column because that's just the way that I know that the project wants to run. So I'm going to make this a 10 by 10 column. And before I go ahead and run the analysis on this, I'm going to go down and look at loads and load combinations. And one of the things I want to point out here, this is a recent enhancement, but we do also for columns have the ability to incorporate P delta. And so that's a requirement according to a lot of the different codes out there, whether you're working in steel, whether you're working in the ACI concrete code, but you can turn on and off P delta analysis or P delta effects on a particular column. So in this case, obviously we want that to be on. Just wanted to make everybody aware that that is part of the design. And since I updated that to a 10 by 10, we can go ahead and click to toggle on the unity check. And so now we're getting a code check of 0.95. That's good. And our compression error or message went away. So we can go look down at our combinations or our calculations, excuse me, and see, okay, for axial capacity, here's how the capacity is being calculated. And using that PCA note, we get our axial capacity there. We can also look at, if we had any torsion, which in this case we don't, but we could look at the calculation for torsion, look at some of the span information, and then finally the rebar detailing. And I really like looking at the rebar detailing because it tells us, the number of bars provided. So we're using number 7 bars here. We're using 15 number 3 bars at 10 inches on center for this column. And then we also get our interaction diagrams, right? Our PM interaction diagrams. So we've got our first one here, and second, and then third. And then we also get some of the rebar detailing, right? So we see all of this information. It's, again, plain to see exactly how RISACalc is going about doing this particular type of design. Okay, so next, I want to go ahead and jump into adding another member from scratch. And so this is, the one I'm most excited about, the one I was, anxiously waiting for our great developers to finish up, which is a composite beam. And so I think in a lot of cases, I meet a lot of engineers in talking on the phone or at conferences or whatnot that talk about doing composite beams, needing to do composite beams one-off, right? Needing to just analyze a beam, check some camber, check some studs, figure out what's going on with a single composite beam, whether it's an existing condition or it's new construction and they just have one beam that they need to validate. And so we can do that with the composite beam feature within RISACalc. And so the first thing I'm going to do before I do anything else is let's go back up to our gear here. Again, we look at our composite beam codes, both for the American codes as well as the Canadian codes. If we click on our composite tab, though, we can see some of the other options that we have for composite design. So we're setting our criteria for min and max composite percentage. And so you can set that criteria. You can set your min and max stud spacing. Also your flange width, if you were going to go to 2 rows or a 3rd row for studs. And then finally our effective moment of inertia. And so a lot of these are just code based, right? And so you don't have to really change anything unless you, the user, need to change something specifically. So I'm going to just go ahead and click apply here. And so let's start by choosing a shape. So I'm going to go ahead and say, and I can just type, right? So I can say it's W21 by 44. And so I'm just going to type that. I don't have to walk through the whole list if I don't want to. I can also always hit the info button and see criteria of that particular hot rolled shape or of any shape there is. I'm choosing a material A992 steel, so that's exactly what we want. And then let's set a span at, let's make this 45 feet, is the member that I'm going to go ahead and check. Now with composites, I have 4 different kind of expandable menu options that I'm going to look at for the properties. The first one is Camber. And so in Camber, as soon as I open Camber here, we get a lot of other visually things in our interface. And so we can select some of these things, or we can just kind of walk through the properties here. So the first thing we can do is to determine whether we want to explicitly define the camber we want to optimize. So again, are you doing a new beam? Are you doing a existing one? Do you already know what the camber is and you need to check that? In this case, I'm going to do an optimized camber. We can go ahead and set the min and max camber. So this is pretty standard for composite beams. We're starting, we don't really camber anything under 3/4 of an inch. We camber up to 3 inches. We're going to increase that camber increment by 1/4 of an inch every step of the way. And then we have our dead load percentage settings, right? So I'm going to say I want 75% of the dead load to be incorporated in my calculation for camber. And I don't want to use the self weight. In this case, I want to go ahead and use the total dead load for that calculation of camber. So I can set that. Next, I can go ahead and expand my deck section. I'll make the camber section smaller here. And then we can choose, hey, are we going to use with metal deck or without metal deck, right? We can choose both conditions here. Very typical, I think most often people are doing with metal deck, so we're going to go ahead and keep that on. I can choose on whether or not this is shored. And then I can start to pick through the criteria here. So I'm going to choose a Volcraft metal deck. I'm going to set my deck type to 3 VLI. So I've got a 3-inch deep deck. My gauge, let's make this an 18 gauge. The deck direction, this is going to be perpendicular. So let's make that deck perpendicular to the beam that I'm running here. Concrete type, let's set at, I don't know, 4,000 normal weight concrete. And then let's set that slab depth at 7.5 inches. So we've got that criteria for our deck created. You know, we could go ahead and now select either the stud section, or I can just go ahead and pick this 1.5 inch dimension, and it's going to open up that stud criteria. And again, similar to the camber here, the stud has some basic options, whether you're choosing to optimize the stud or whether you're explicitly defining, hey, I have this type of stud here on the member. So if I have explicit, then I define the number of studs on the beam, right? I've got 6, well, in this case, 6 is a very minimal number, but I've got, 28 studs on this 48-foot beam or something like that, right? In this case, I'm going to do optimized, and so it's going to automatically count the number of studs. I can set my height above rib, so that's that 1.5 inches here. I could go ahead and click and set my stud diameter, my tensile strength of the stud, and then the offset. That offset distance is here, shown here graphically, so that's where our first stud starts, away from that support condition. Now that we have most of our information for camber, for the decking, for the stud setup, I'm going to go ahead and open up the beam layout, right? And so this is the criteria that we need in order to define the effective width, right? In order for it to automatically calculate the effective width, since we're not building a 3D model and it can't see the beams that are next to it, we're just looking at one individual beam. We needed to say, okay, is this a slab edge on the left and the slab edge on the right? Do we have an adjacent beam? And if so, how far away is that adjacent beam? In this case, I'm going to keep that distance at 5 feet each. So basically we have, that amount of beam spacing between individual beams, and we'll use that to calculate our effective width for this particular beam. Okay, now if I switch over to my design tab, again, very similar to what we saw with the wood member. We have our bracing for beams. Again, unbraced lengths are pretty typical no matter what type of beam that you're using. In this case, I do want to set an unbraced length, but I'm going to set an unbraced length for the top brace. So the top brace, I'm going to say the top brace is fully braced along its length by the deck and by the studs and by the concrete. So we're just going to keep that top braced at fully braced. I could set a CB factor, or we could just let it auto calculate like we're doing. And then we also have the ability to do so we're also optimizing and checking for deflection here as well. So we're setting our deflection ratios. That's super important with a composite beam, especially when you're incorporating camber, right? And so we can set our deflection criteria, our ratio criteria. So we set a dead load, a live load, and then a total or dead plus live load deflection criteria, right? And we do have a little note here that live load will be not taking always the live load, but the controlling of the live load, the snow load, the roof live load, the special live load. So whatever's controlling out of that case, depending on what you've input as your categories, it'll take that into account. And so now I can go ahead and click loads. And for loads, let's go ahead and add a few different things. So I'm first going to start with a distributed load. And we can see, because we're doing composites now, we have some different load categories for distributed loads, right? Some pre-dead load, construction live load, post-dead load, right? All the very typical loading conditions that you have for a composite beam. And so let's start out with a construction live load. And let's make this 250 pounds a linear foot. Oops, here we go, 250 pounds a linear foot. And we can make that along the entire length. That's good. Let's go ahead and add another member. So let's say this is going to be a post-composite dead load. And let's say 100 pounds a linear foot. And now this is going to be additional load in addition to the self-weight of the beam, the self-weight of the deck, the self-weight of the concrete, which is already incorporated by default. Let's go ahead and I'm going to add 2 more distributed loads in this case. The first is going to be a live load, and we'll make this again 100 pounds a linear foot. But I don't want this, I don't want this load to be, completely along the full length of that 45-foot beam. I'm going to say that's from the 0 to 20-foot condition. So we've got that space there. Maybe we've got a beam where we've got one type of occupancy on one side of the beam or side of the hallway or something, and another occupancy on the other side. So maybe we've got our corridor and then our classroom or something like that, whatever would cause this difference. So that's the first one we want to add. And then for the distributed load, let's go ahead and add in a second one. We're going to increase this one a bit. So let's go to 150 pounds a linear foot. And in this case, now we're going from 20 feet to 45 feet, right? So we've got that 0 to 20 and then 20 to 45. And so again, we could click on these. If I click on some of these dimensions, I'm getting those, I'm getting that information back. The next thing here, I'm also, again, creating our load combinations, right? And so we are using an LRFD load combination or LRFD design. And so again, I can come into our settings. I don't want to use any ASD, so let's get rid of those. And for strength, we're just using LRFD combinations. So in this case, again, just doing a really quick kind of sanity check, if you will, 1.4 with the dead load, 1.2 with the live load, and then different pre and post live load combinations. So things look good. And then on the deflection load combinations, again, we see our deflection load combinations as we would expect, right? So we've got our pre-dead load, right? So pre-dead load is what, right? It's self-weight of the beam, it's deck self-weight, it's self-weight of the concrete, and then it's any construction dead and pre-construction dead load, or pre-composite dead load, excuse me. And we've got our regular dead load, again, including the self-weight, deck self-weight, and those pre and post dead loads. And so we can see this very plainly written out for you so that you know exactly what this particular composite beam is going to do. So the next thing we need to do, obviously, let's run the design. So I'm going to go ahead and click on to toggle on our Unity check here, and we should get an output, right? So we do, great. And so we've got, it says our governing load combination in this case is 1.2 pre-dead load plus 1.6 construction live load. So that construction live load and pre-composite dead load is our controlling condition. We can see our code check at 0.64. We've got a percentage composite action just over 26%. We're seeing the beam, so it's a 21 by 44 with 20 studs and a 1.25 inch camber. So all that looks good. And so we can go ahead and turn on some of the criteria, some of the information. So let's go ahead and make this detail report smaller. And so we can turn on the moment. One of the things I didn't show earlier though, but is if I go ahead and just run my mouse through kind of the area underneath the moment diagram here, we can actually see the moment at different locations. So maybe if we look at shear, right, I can see where I'm getting pretty close to 0 here, and then working my way out to the max shear conditions, you know, at our boundary conditions or at our supports. And so we can see that criteria. I can also, in this view drop down where I'm seeing everything for strength right now, I can go ahead and flip this to the governing deflection load combination and see the deflection, the governing deflection combination. So what we have here, and then the deflection ratio. And so with that, I can go ahead and turn on our deflection, our deflect shape, right? And again, I can kind of toggle along the line here to see deflection at a variety of locations along this member. And so we can see exactly everything that's getting into this. And so let's go ahead now, you know, we've looked at that. Let's go ahead and open the detailed report because again, this is another place where I think RISACalc really shines. And again, because RISACalc and RISA 3D actually use the same engine, you know, we have a lot of that in the background. We have a lot of this great detailed reporting that's available to you. And so I'm going to go ahead and open up the detail reports. So let's look at our calculations here. And again, we see our basic Unity checks. So that's great. And we can start off with non-composite bending, which is actually controlling here because we have a lot of load that's applied before composite action is achieved. And so we can see the steps of non-composite bending. So calculating our CB factor, checking our slenderness ratio, getting through, okay, we've got a compact flange and a compact web, check yielding, get ultimately down to that Unity check, right? And we can look at our composite bending. So all this, everything that goes into calculating this C factor and coming in and calculating all the other information that ultimately brings us to our composite bending Unity check. The one I really like to look at is the studs, right? So we see stud information and then our shear capacity of each stud, our number of studs. So we've got our total required force that's required, and then our Q total. So that gets us to our percentage of composite action rate. And then finally, we can look at our deflection information. So just very, kind of our basic deflection. So under which load condition or loading combination do we have a certain deflection with a certain ratio? And then, what's the limit, right? And then that's where we're getting that ratio comparison against that limit, right? And so that a controlling one is in our kind of our total load deflection here, right? Is our controlling ratio, right? And that governing ratio is written. And then finally, just a basic composite detail, right? We have got a W21 by 44 with 20 studs and 1 1/4 inch camber. Now, we've seen this detailed report here graphically, and that's great. I can also just download that detail report. So it's just going to generate the PDF for you really quickly here. And then once that PDF is generated, it's available to you here in your browser, right? So you can either open it in your web browser, right? So if I just click on it, open it in my web browser and see all the different information of this particular check. We could also, since whatever you're using for your default PDF viewer, you can also open it there as well. So if I was using Bluebeam, which is a sister company of ours, I could go ahead and open up in Bluebeam as well. So the last thing I want to do, the last kind of element that I want to look at is a steel joist. And so again, we've looked at designing a few members from scratch. We looked at looking at a member, existing member. I'm going to go ahead and open this roof joist. And so I'm looking at a roof joist here. And so my roof joist is 27. I've got an explicitly defined, I've got an existing roof joist. It's 27 feet long. If I look at my loads here, let's see, I was playing around with this one. So let's make sure that these loads are the full length here. So I've got 27 foot of load. I'm looking at a 20K5. And if I look at my unity check right now with this particular member, I've got no problems. This is existing. Let's maybe say this is how it was designed to begin with. But, I was talking to, or I was contacted by the owner or the architect, and they're doing a renovation of the structure, and they're asking us to evaluate if we can either put some equipment on the roof or we can hang something from the joist. And so we need to add some point loads, right? And so while everything works now, we need to come into our loads and we need to apply some point loads. And so I'm going to come in here and say, because we're looking at, okay, a 27 foot K series 20K5, we can go ahead and look at that. But I want to go ahead and look at adding loads. So let's go ahead and add a point load. And let's say this is going to be a live load, and it's going to be, let's say 0.35 kip, so 350 pounds. And let's add that at 8 feet. And then let's go ahead and add in another point load. Same thing, 350 pounds. And let's make this at 18 feet this time. So we have this condition now, right? So we're adding these point loads, and so we need to check this. So we just run our unity check here, and we do get an overstress. So we're about 6% over our code check. We look at our properties here. Now it is giving us a special designation in this case because it's got point loads, and we're not totally uniform in our load per the requirements of SJI's joist manual. We can also look at our calculations and look at our capacity check, and that's really what's failing here. So we're seeing we're required to have a, taking this and rendering these point loads into a uniform total dead load and a uniform live load. We're getting a requirement of 0.406 kips per linear foot, and we have 0.382 kips per linear foot. So we're failing, but maybe this is where we now have to make decisions. Do we brace the joist, and that's something then that you would discuss with your joist manufacturer. We could also see the deflection checks. So in this case, our deflection checks are good. So we're okay for dead load, live load, and total load deflection. And so we can see this type of information if we're doing an explicitly defined joist. We could also define optimize a joist, right? If we just needed to look at one joist. So if I just click the plus button over here, maybe I want to define a joist. So let's make it 50 feet. And when as soon as I put in 50 feet, now I'm still in explicit here, but it's telling me, hey, at 50 feet, you can't use a 10K1. So it's going to start to use the member that it can actually start with at 50 feet, but I actually want to optimize. So I don't want it to pick a member for me specifically, but I do want to pick the joist series. Now I can choose to use all if I want, but in this case, I'm going to go ahead and choose that I want to use an LH series joist, maybe because I know that that's what my joist manufacturer has available at the plant that's nearest to me. Again, I can set up some design criteria, dead load, live load, total load. And then we can apply some loads. So let's go ahead in this case and apply a distributed load dead load 35 or 0.35 kips per foot. And let's apply that at the whole length. And then I'm going to go ahead and add in a tapered line load here in the live load condition, the whole length as well, right? And again, so we're creating those load combinations, and remember, we haven't defined the criteria, we haven't defined the joist itself. So when I hit the unity check, it's going to do an optimization real quick. And so it gives me a 98% unity. So that's good. Okay. And if we look into properties here, okay, so it designed for us a 32-inch deep LH14 special, giving us, again, that special designation because we're doing this tapered area load, or excuse me, tapered line load. And we're outside that basic, the criteria or the requirements of a uniformly distributed line load. And so it's putting that special designation on it, just like we would see a special designation if we were doing this in RISA floor or something like that. And so whether you're optimizing or explicitly defining your joists, you can go ahead and check an existing, or you can define and calculate new. And in this case, all the information is the same, right? So we've got our loads defined, our load combinations defined, and we have the other material or other information. So before we go ahead and go, I want to jump back to the PowerPoint for a minute. I do want to talk a little bit. We've gone through a lot of the different components here. I want to talk a little bit about kind of some of the resources you have, right? So before we end this webinar, let's talk about some of the resources that are currently RISACalc. So first and foremost is the help, right? So if we go ahead and just click help here, it's just going to launch the help file. And so the help file online is just like the other help files for our other software that you've come to learn from and love. You've got, it's searchable, it's organized, you have all the information that you want. One of the things that I want to point out is if I'm going to open up technical support here. And because I have a developer license, I don't have this criteria, but as a user, if you go ahead and click the profile button, you can go ahead and click RISA support. And what that allows you to do is automatically, give us a message, gives your name and email address, but can send your model directly to our support team. So if you're having an issue, if you're wondering why something is calculating the way that it is, and you want to send us a model, and since this is in the cloud, you don't have a model file to download that you can attach to an email, this is the best way to do this, right? And this goes right into our technical support group. So they'll get that and respond to you promptly with some assistance, with some help for your RISACalc model. The next thing is I'm going to go ahead and jump just into YouTube here. So right now we've been creating YouTube. We've got a YouTube playlist for RISACalc, and we've got different videos for all the different components and the different materials. So whether it's aluminum, you want to see a beam or column in aluminum, a beam and column in cold form steel, you want to see a concrete member, steel joist, composite beam, or what I've called the definitive walkthrough, right? Just kind of all, here's the interface, here's the setup, here's how you use things, here's where things are. You can use this YouTube playlist to go ahead and learn about RISACalc, right? And understand, how to do something in one of the various materials. And as we add more functionality, we'll continue to add videos to this that correspond with that added functionality. Next thing I just want to show is articles, right? Our website is flush with articles and all different things RISA, but RISACalc has its own section as well. So if you just go to our website and you're searching through the articles, you can click on the RISACalc button and you'll see all of these different articles. So whether it's, announcing new content, or it's a new release, or it's content specific to a material, whether all, our videos or our articles, all this stuff will present itself in our website as well. Now, finally, I'm going to just go ahead and jump back to the RISA homepage, but just wanted to mention, one of the great ways, this is a web-based program. And so, it offers us new and exciting ways for people to, buy the software. And so whether you're an existing user or you're a brand new user, you can buy the software. And so if you click on buy as a new user, you can just go through a regular buy process and purchase RISACalc. Also, for the administrators of your account as an admin, you can actually just go into your RISA customer portal account and click the buy button to buy RISACalc. And the great thing about RISACalc is you have two options for subscription, right? So you can either do an annual subscription like all the other RISA products are, or you can actually do a monthly subscription. So if you're not sure if RISACalc is for you and you just want to try it out for a month, you can go ahead and just get a monthly subscription. Or if you want to get a license and then a couple months later you need to scale up, scale down, you could just scale up for a couple months and grab a second license, on a monthly basis rather than, on an annual basis. Now let's go ahead and jump back into our PowerPoint here. Sorry about that. Let's go ahead and grab the actual PowerPoint. There we are. And so a few things before we go ahead and wrap things up here. The first thing is we want people to try this out. We want people to, give it some time and see, what's what, and play with the functionality. Give us feedback. Tell us what you like. Tell us what you dislike. And so go ahead. If you're interested, we're doing 7-day full trials right now. And so hopefully that gives you the time to, and that'll be a cloud-based network license, on an account. So you can have more than one person access it. You can share that with our other users. And so if you're interested in a trial, please send an email into our main account. So this is info@RISA.com, and then those will get forwarded to our sales team so that they can process you and be in touch and process you a trial. The other thing I want to mention is, like I mentioned at the very beginning, we want your feedback, and we don't just want your feedback, we need your feedback, right? And so for everybody that's attended here, I'm going to be following up this webinar with an email, personal email from me, that will have a link to fill out a survey. And so that survey, super quick, it's one question. And that one question is, here are the features and functionalities that we've heard from, our current installed base and from other users who've been trying it out and stuff, that other components that they want. What do you want, right? And so you'll be allowed to, I think there's 15 or 16 in there, plus another section. You can go ahead and just choose your top 3. Just let us know what you want. And we'll go ahead and share the results of that survey once we get in all the results. And then, that'll help us to identify what's next from a development standpoint, because we know that unless we're developing what our customer base needs, that's not going to help that's the way that we need to do it in order to help grow our user base and help to grow people's use of the software. Finally, because I get this question all the time, you will also receive another email from our system with your PDH certificate. So I'll have a link in there to download your PDH certificate. And so you can go ahead and get that, and that should be sent out. Once I get this all uploaded in the system, it should be sent out in the next couple of days. And finally, if you missed anything during the webinar, we'll be posting a recording on our website and on our YouTube channel in the next few days. And so if you have any questions on the webinar, if you have any questions on RISACalc, you can send an email into info@RISA.com, or you can email me directly. My email is just benf@RISA.com. If you have questions on functionality or how the subscription works, with that network license in the cloud, right? Just send those over. We'll be happy to answer anything we can. So with that, I really appreciate everybody's time here today. I appreciate all your questions. It looks like Gabby's been busy in the Q&A section answering questions like crazy. And so we'll leave the webinar open for a few more minutes so that if there's any other questions, Gabby can answer those. But thank you so much for your time today. We're excited about RISACalc. We're excited about the opportunity for our customers who love our other software to try it. And we look forward to the future and developing a tool that our customers can use and that we can be proud of. Thanks very much, guys.